Hello everyone. Now I am going to give a demo of a project. The title of a project is Virtual Restaurant Using Web Services and Data Analytics. The main aim of a project is we see people searching for the food of best price with offers in different applications, which takes more time. So we have decided to get the data from different vendors, integrate them using web services, and recommend users the preferred food at best price. The application also stores the details of the users and recommends.
Here I am going to explain how the recommendation model has been implemented. To implement the recommendation model, item-based collaborative filtering is used, and to recommend top 5 similar food items, a nearest neighbors algorithm is used, and to evaluate the model, we have used RMSE root mean square error, and Jupyter notebook is used to write the code, and the language used is Python. Okay, first import the files required. So numpy as np, pandas, and from math square root function. From scikit-learn metrics, mean squared error is used for evaluating, and pairwise distance is used to measure the distance between two vectors, and the nearest neighbor algorithm. To implement recommendation model, dataset is required. The dataset is designed by taking 25 food items from different restaurants available on Swiggy and Zomato, and 5 different user ratings to the food items are taken. This is the food item dataset taken from Swiggy and Zomato, and it is taken as item data. And these are the ratings given to the food items by the 5 different users, and this data is taken as ratings data. Now we are reading the ratings data set as ratings, and items data set as items data, ratings data. Now we are printing the items data set, items dot head. Now we are merging items data and ratings data using item id, and it is assigned to new data frame. Now we are interchanging the column and row using pivot table. Now in the index we have taken user id, and the columns item name, and the values are rating values. Here we can see clearly that user 1 has rated for the item 1 and is not rated for item 3, so it is nan value. Similarly, we have printed all the ratings given by the 5 users to the food items. There are 25 food items, and user may not rated all the food items, so we are now finding what are the food items rated by the users. For that, create two dictionaries, rate and row indexes. Rate dictionary is used to store the food item names, and row indexes is used to store the indices, and which will be useful when we are checking the similarity score to reference back. Now we are running for loop till the number of rows in missing pivot item rows. In rows we are taking the length and row index, row values, and we are zipping into the list, and we are combining only when it is not equal to nan. Nan means it is not rated by the user. Now in the index we are collecting the indices of the food items already rated, and we are collecting the food item names in the row names, and the index values are assigned to the row index dictionary, and food item names are assigned to the rate dictionary. And these are the items that user 1 has rated previously and user 2 has rated previously, user 3, user 4 and user 5. So here we got the food items already rated by the user 1, 2, 3, 4 and 5. And now we are applying in nearest neighbors algorithm to the pivot table. So here n value equal to 5, so that we are finding 5 nearest neighbors, and the algorithm used is brute and the metric used is cosine. Here pivot table dot t dot values means we're gonna transpose this table, so that the item names is comes to index and user ID index is changed to column. And now we are getting item distances, item indices. So now we are gonna check the similarity between items. For checking 5 similar items associated with each item, we have taken item dictionary and run for loop till pivot table dot t dot index, and now we are getting the item indices and the column name. Now we can check the similar items associated with each item. See, this item is most associated with this item, and these are the remaining 4 items associated with this item. Similarly, chicken BBQ from Gabru Bristow and KF is mostly associated with chicken BBQ from Gabru itself. And second similarity is chicken noodles and paneer butter masala, so on. Now we got the food items most associated with each other, and these are the most associated food items to each other. And we need to recommend these food items to the individuals depending on the food items they rated past. And in the recommended food items, we are not showing items already rated by the past, but only food items most associated with their past ratings. So for that we are creating top recs dictionary and run for loop in row indexes from above. Row indexes, so here row indexes contain food item indexes already rated by the users. Using this dictionary, I am looking through it. For I in item indices, here item indices, I want to find all the indices that are most similar to the food items that they already rated. I want item indices and item distances, and combine item distances and item indexes, and created another dictionary and distance D and index I in combine. If index I not in V, cause I don't want food items already rated by the user. We are not recommending the food items already rated by the user. We are recommending most associated food items depending on the past ratings. So we don't want the food items already rated. Now created dictionary and got the keys and got the values and zipped and sorted the distances, and it will be numerical value from most similar to least similar based on the food items they already rated. And here I use the original pivot table and got the column names, that is the food item names, and these are the recommendations, and K is the actual user. I am making recommendation that the food items have not rated before based on the previous rating. So here we get the recommendations that user have not rated before. Okay, when we run the top recs dictionary, so we got the recommendations to all the individual users. So for the user one we are recommending these items, and for user 2 we are recommending these items. This all depending on the past activity, but if user 3 has rated chicken biryani in past, that item is not shown. We have excluded that item here. Similarly, for all the users we have excluded all the items previously rated. Here we can check the similarity score for each item what we have recommended. And now creating function get recommendations, and here the parameters are user and number of recommendations. We are making top 5 recommendations, so equals to 5, and if user is greater than the length of pivot table dot index, that means if we pass the parameter 6, then it is we have only 5 users, then it shows the out of range there are only this much users, and try again, and it shows the length of the pivot only 5. And else if the user is 1, then it will show, it will tell the what are the items, food items that have rated in the past, and the food items recommending depending on the past activity. So here the case the actual user, and in top recs we're gonna see in the top recs, and if the user equals to K and the number of recommendations is 5, and we are printing the similarity score to that. And when we send the parameter as 1, so this means user 1 to this function. So these are all the items rated by the user 1 past. So these are the items, depending based on these items we are recommending these items to the user 1 with the similarity score. So these are the recommended items, and we can see here these are the items rated by the user 1 pastly, and these items won't be recommended here. Depending on these items we made a similarity score, and we sorted and we recommended, but we are not printing these items rated pastly in the recommendations. We can see when we pass the user 1 as a parameter, we are getting the food items already rated by the user 1 past, and these are the recommendations. So we try sending 6. See, out of range there are only 5 users. Try again, and again when we send 3, user 3 as a parameter, and these are the food items rated by the user 3 past, and these are our recommendations with the similarity score. And now we are making rating predictions for the food items that user have not rated before. We are making item predictions. These gonna predict the rating of what food items are associated with another food items. So here item distances 1 minus item distances actually get the similarity score, and here is the prediction formula. And ground truth for the original values in the pivot table, and item distances and indices to reference back to the ground truth and to evaluate predictions. And now RMSE prediction from here and ground truth here, and looking at the prediction and ground truth. Prediction and indices are non-zero, and we don't care about zeros. Non-zero and flatten. Look for non-zeros, ground truth, and return square mean squared error, prediction and ground truth. So here error rate can be calculated using predictions and ground truth, and accuracy is 100 minus error rate here, and RMSE is the error rate, so we're gonna take the value of error rate. So the accuracy of the implemented model is 97.716, and the error rate RMSE root mean square error is 2.28416.
Now I'm going to give a quick demo of our web application. So before that, let me get you through the code. So this is our app.js file. We have different files like show.ejs and a recommendations file for the recommendation page, and index file for the home page, and then we have a knn.python file for recommendations model, and then we have login page, and then we have sign up page. So in app.js we require all the required packages like express, body parser, and then we are going to use Amazon DynamoDB. We are going to connect to the Amazon DynamoDB, and then we use different HTTP GET methods to get the request, and then we'll use different routing algorithms to route to different parts of the web applications, and then we have used different algorithms for checking the user ID and password. So now let me show the demo of a web application. So now I'm going to start the web application. So you can see the server has started. I'll copy the URL and I'll just paste it. So I've used Cloud9, which is the best software for developing a web application, because it consists of it has a default softwares installed, and Amazon DynamoDB is the database which I've used. So if I click on get started, it comes to the home page where all the images of the food, and if I click on more info, it gives the more information about the food. If you see deals from Zomato, it has this much of price and offers, and we have this much of price and offer in Swiggy. So I'll go back to the home page. If the user has not signed up, the user can sign up using this button. If the user clicks on this button, it comes to the sign up page. So if the user doesn't give any details and submit it, it gives invalid details. And if the user just gives the email ID and submit it, it gives invalid details. So I'll just log in as Dinesh and I'll give a password as 123, and if I submit it, it signed up successfully. So you can see that the data will be stored in the database, DynamoDB database. You can see that Dinesh has been stored with password and created on, and ID will be assigned to it, and updated on the date and time will be shown here. So I will go back. The user can now log in. So now when I click on login button and given the details which I have signed up with, so you can see that it recommends a food to that particular user. Now the user can click on more info button and he can see that deals from Zomato and the deals from Swiggy to that particular dish. Now the user can also go back, log out, and you can see it comes to the starting page of the web application. And also we can again sign up with different username and password. So signed in successfully. So if I click on login button and I'll give the email ID and password and submit it. So you can see that it recommends another dish to this particular user. So like this, it recommends different items to different users based on the recommendation system. Hope you enjoyed it. And when the user gives an invalid login and password, suppose this and this, submit, it gives wrong email and password. And if he doesn't give the password, it gives invalid details. So we'll go back.